Hello viewers, welcome to this next lecture on the MOOC course on mathematical portfolio theory. You would recall that in the last class we started talking about utility theory and we looked at the economic interpretation of the utility functions and how we can actually use the utility theory in terms of assigning utils or numerical values amongst various investment alternatives. And then we concluded by looking at an example highlighting the fact that when we talk about utility of a wealth level, given the fact that the utility of a wealth level is a random variable, we need to calculate what is the expected utility, and then we are driven by the maximization of the expected utility amongst different alternatives in terms of investments. In today's class, we will elaborate a little more on a notion of the risk appetite of individual investors, and we will draw motivation from the fact that the last time we talked about three categories of investors in terms of the risk appetite, namely risk averse, risk loving and risk neutral. So, let us begin this lecture with a prelude to that discussion, and we will then discuss the characteristic of all these three types of investors from the point of view of the nature of their risk attitude. So, we start off with, as I mentioned, we will talk about risk attitude. So, the motivation for this is that we need to recognize the fact that investors have varying appetite and preference for risk, and accordingly we dwell upon the three types of investors, and we have already introduced them in the previous class, namely the investors who have a risk aversion, who are risk loving and who are risk neutral. So, let us start off first with the investor who have the attitude of risk aversion. So, we first begin with the concept of what is known as the marginal utility of wealth. So, this is a fairly well established economic concept which is defined as the additional utility a person gains from a small change in her or his wealth. So, the economic rationale for the same is based on the premise that more wealth is more desirable than less wealth, which is sort of an obvious statement, and accordingly it follows that the marginal utility of wealth for every rational investor will always be positive. So, just to sort of look at the crux of the matter, we say that this concept of marginal utility of wealth is defined as the additional utility a person gains from a small change in his or her wealth. So, that means given a certain wealth level, say W1, the corresponding utility is going to be U of W1. So, if it is changed to, if the wealth increases to W2, then the utility obviously will change to U of W2, and then essentially the additional utility, that means the difference between U of W2 minus U of W1 as a result of the wealth level changing from W1 to W2, this is the basis of the concept of marginal utility of wealth. And accordingly, because of the obvious attitude of any investor that more wealth means they essentially get an additional utility. So, obviously, from that point of view, the marginal utility of any rational investor will obviously always end up being positive. From the mathematical point of view, so since this is a mathematical portfolio theory course, so we will have to look at the mathematical perspective of this. So, accordingly, the marginal utility is given by the first derivative of the utility function with respect to the wealth that is a marginal utility of wealth is given by u prime of w, which is du dw, and this is greater than 0. Alright, so another way of looking at it is that u as a function of w, you expect that for a rational investor this is going to be an increasing function, and that is the reason why the marginal utility, which is defined by the additional increase, or it is essentially the rate of change of the utility vis-a-vis the wealth level. So, that is the reason why the definition of marginal utility, in order to capture that relative change in the utility corresponding to a unit change in the wealth level as the marginal utility, and since this is an increasing function. So, obviously, the marginal utility defined by u prime of w, that is going to be positive. The next step would be to determine whether the marginal utility. So, we now look at the nature of the marginal utility itself. So, we have to determine whether the marginal utility is increasing or decreasing, and this is determined by the sign of the second derivative of the utility function. So, therefore, the decreasing marginal utility. So, it turns out that this is actually a decreasing. So, the decreasing marginal utility is given by u double prime of w less than 0, that is d square u d w square, this is going to be less than 0. So, this means that your u prime is greater than 0 and u double prime is less than 0 in case of a risk averse investor. So, graphically it will look like this. So, accordingly what you will have is that this is going to be something like this. So, this is an example of a decreasing marginal utility. So, the interpretation of this is that as suppose that your marginal your utility, the wealth level changes from W1 to W2, then this difference in the or the change in the utility will be given by this. So, this is always going to be positive since it is an increasing function, and you consider two scenarios where your wealth level changes by identical manner. So, in first case it is from W1 to W2 and second case is W3 to W4, but these changes are identical. Then you observe that the additional utility that you get when you change from W1 to W2 is more here than the additional utility that you get here from a change of W3 to W4. So, while so the interpretation of u prime of W greater than 0 is that as your wealth level increases, your utility obviously increases. That means the satisfaction level that you get is increasing. But for a risk averse investor, if you have identical change in the wealth level, so in this case I say that the wealth changes from W1 to W2 and another scenario when it changes from W3 to W4. So, that means the W2 minus W1 is taken identical to W4 minus W3. Then you see that U of W2 minus U of W1, which is the consequent change in the utility level or the marginal utility, is going to be more than the marginal utility that is given in case of movement from W3 to W4. So, this means that as your wealth level increases, identical increase in the wealth level results in lesser and lesser corresponding increase in the difference of the utilities or the corresponding increase in the utilities, and that is the consistent with your statement of u double prime of W being less than 0, while you have u prime of W greater than 0. So, an interpretation of this is that if you have a very low net worth individual, an additional amount of say 10,000 will give a huge amount of additional utility, but if you have a very rich individual, an additional amount of 10,000 or an increase of 10,000 in their wealth level is obviously not going to give that much of additional satisfaction as compared to somebody who has less amount of money and who gets an increase in their wealth level of 10,000. So, in summary, what you can write is that decreasing marginal utility leads to risk averse behavior and economics always assumes that a rational investor is risk averse. Okay, now we will make a sort of a comparative study of the three types of investors in terms of their risk appetite through a specific example, which will then also at the same time reconcile with a general setup. So, accordingly, let us begin with the case of an investor. So, suppose an investor has a utility function with decreasing marginal utility. So, it is basically u of W will have u prime positive and u double prime negative. Now, suppose that the investor's wealth level is 1000 and is offered an investment opportunity where the investor can gain an amount of 300. So, let me just identify it with some z tilde with probability half or losing 300 with probability half. And the question, now this investor is risk averse because I have said it is a decreasing marginal utility. So, the question is that should the or would the, so we need to see it from the point of view of the investor, that whether he or she would be interested to enter this investment opportunity. And the answer to this is that it depends on investors' attitude towards risks. So, I am saying that it depends on investor attitude towards risk because I am going to use the same example to look at all the three cases. Okay, so let us look at graphically, let us see what this situation looks like. So, this is my wealth and this is my U of W. Now, since I have said that the investor's utility function are decreasing marginal utility, so the graph will look something like this. And let us identify the initial amount of 1000 with the notation W naught, and the gain can be 300, which means that either it can go up to 1300, and let us identify with W subscript plus, and it can go down to 700, let us identify this with W minus. Okay, so that means the corresponding utility of W minus will be here, the corresponding utility for W naught is here, and this is nothing but utility of expected wealth before the investment, and for W plus the utility is going to be U of W plus. Okay, now once you have made the investment, remember that it can either go down to 700 with probability half, or it can go to 1300 with probability half. So, the expected utility will be somewhere here. So, this means that this is going to be the expected utility. So, this is going to be the expected U of W. So, in this case, when the investor gains, the wealth increases to 1300, which I will denote as W plus is equal to W naught plus Z tilde. So, I will identify 1000 as W naught. So, please make a note of it. Now, in this case, so the other alternative is, in this case, when the investor loses, then the wealth decreases to 700, and you will identify this with W minus, which is W naught minus Z tilde. And in the first case, the utility is U of W plus, and in the second case the utility is U of W minus. Okay. So, thus the expected utility, so here you please remember that it can either be U of W plus or U of W minus with identical probabilities half and half. So, thus the expected utility from the investment is E of U W, which is half of U of W plus So, it takes the two values, the random variables u of w plus and u of w minus with probability half each. So, that is the reason why we chose u of E w was here, which is the corresponding expected wealth level, which is half of. So, it is basically half of u w minus and half of u w plus, which is at this height. Okay, so next thing what you can say is that whether or not, so once we have this setup, so whether or not the investor is willing to get into the investment, that means this is like a binomial kind of an investment, depends on whether the investor's expected utility increases or decreases by getting into the investment. So, it is obvious that the investor has an amount of 1000 or W naught, and they are obviously going to get into the investment only if they see that they have the possibility of the expected utility being more than the utility of the amount that they are currently holding, and that is what is going to drive home their decision. Okay, so let us now introduce a few notations. So, remember that W naught was the initial wealth level. So, this is U of W naught is going to be the investor's utility of wealth before the investment. Now, there are two possibilities. If E of U W, that is the expected wealth after investment, is greater than U of W naught, then the investor gets into the investment, and in the second case, if E of U W is less than U of W naught, then the investor does not get into the investment. So, from the figure, it can be seen that the investment decreases by U of W naught minus E of U W. And so, the investor will not get into the investment, and this is a classic example of risk aversion behavior. So, remember, just going back to the graph, you observe carefully here, this is the wealth level that the investor would have without making the investment, and this is the wealth level that they are expected to have if they invest, and you observe that this wealth level after investment is less than this wealth level, and the difference between these two, that means U of W naught here minus expected utility of W, that is U of W naught minus expected utility of W, this is going to be the investment decrease as a result of the investment or the value decrease of the utility, and then that is the reason why the investor is not going to get into the investment, because the investor is risk averse. And this has happened because the graph is a concave graph. That is the reason why we have this quantity ending up being negative. Now, note that a risk averse investor's utility function will always be concave, right. So, this means that it is going to look something like this. Now, however, the risk averse investor can get into risky investments if they see that the odds are in their favor. So, that means, if the expected utility is going to be more than the utility of their current wealth level, then of course, the risk averse investors are likely to get into the investment. So, risk aversion does not mean that the investor will not take any risk. It just simply means that they were willing to take the risk only if they see that their expected utility, which is a manifestation of their likelihood of making a a gain, is more than the whatever is their initial investment. So, U of UW, if it ends up being greater than your U of W naught, then obviously they will get into a risky investment. It is just that they are going to be, their risk averse nature will ensure that they will have this criteria set up in order to determine whether they want to get into the risky investment or not. Okay, so now we come back to the example. So, from the point of view of the investor, getting into the risky investment decreases the utility by U of W naught minus E of U W. Okay, so now suppose that the investors utility after the investment equals the utility of holding a certainty equivalent which will abbreviate with CE, amount of cash. So, the definition for certainty equivalent is the certain amount of cash that leaves the investor indifferent between a risky investment and the certain amount of cash, which is C, the certainty equivalent. So, we will look at this, we will revisit the graphical interpretation of this. So, you have W, and so I just want to add one more thing. So, here this means that you will have E of U W is equal to U of C E. Okay, so, this gives the definition of certainty equivalent. So, in this case, so let us look at the graph again. So, here we had W minus W naught W plus. So, here again this is going to be U of W minus U of W naught, and here you will have U of W plus. okay, and then you join these two lines, and this point. So, here from this point I will calculate the expected utility of W. Now, please understand that the expected utility of W. So, what you could have is that this expected utility of W, if it is equivalent to the utility of a certain wealth level here, then this wealth level is called certainty equivalent. So, just to explain this, so what we have is that once we have made the investment, then the corresponding expected utility. So, in the previous example it was given by half into u of W plus and half of u of W minus. This gives the expected utility to be this value here. Now, we extrapolate this utility value of utility to hit the utility curve, and then I drop down to calculate the corresponding value on the wealth axis W, which gives me this utility. So, this amount of money is what you call as the certainty equivalent, and it is different from W naught in this case. So, accordingly what happens is that, so there is a difference between W naught, which is the original amount, and the certainty equivalent, or the amount that gives the same utility as the expected utility. So, this difference that we have here, this is known as the risk premium, and the risk premium, this is given by phi of W naught Z tilde. This is given by E of W tilde, that is the expected wealth that you have, minus C E. Okay. So, in this case the risk premium, so here W naught is what we write as E of W tilde. So, the risk premium is nothing but this is going to be always greater than 0 for risk averse investors. So, in summary, and this is the summary for the risk averse investor, the utility function for a risk averse investor is concave and has the following characteristics: that utility of the expected wealth is going to be, so that means this one here, this is going to be greater than expected utility of W, and which is equivalent to u prime of W greater than 0 and u double prime of W is less than 0. All right, we next come to what is known as the risk loving behavior, which is the opposite of the risk averse behavior. So, in this case the risk loving investor typically has convex utility function and will make, so and the risk loving investor will make riskier decisions about the same investment that we just considered. So, let us look at this graphically again. So, this is W u of W and it is a convex function. Now, this is W minus. So, correspondingly I will have u of W minus. This is W naught. So, this is going to be u of w naught, which is nothing but the utility of the expected wealth as before. And this is w plus. So, this is going to be the utility of w plus. Now, what is the expected utility? So, the expected utility will be basically given by the line joining these 2 points. So, it is basically half of utility of w minus plus half of utility of w plus, and then so this is the corresponding value that we have here, and so what we will have now is this value is going to be expected utility of the investment. And once I extend this here, then this point here is going to be my certainty equivalent, and this is going to be the risk premium. So, here you observe that the expected utility from the investment, so that is here E of u of w, this is, so this is the expected utility from the investment. This is greater than u of w naught. So, in other words, the investment by the risk loving investor increases the utility by E of u w minus u of w naught. So, now we start off with the notion of certainty equivalent. So, the risk lovers, so certainty equivalent in this case will be defined in a similar way. So, the risk lovers utility after the investment equals the utility or utility of holding a certain amount of cash, namely certainty equivalent. So, that means in this case the risk premium, which again is denoted by phi w naught of z tilde, this is equal to E of w tilde minus C E or less than 0. So, in summary, for a risk loving investor, u of E w is less than the expected utility of w, right. So, this is less than expected utility of w. And this implies and implies by that u prime of w is greater than 0, which is always the case, but in this case I will have u double prime of w greater than 0, because this is a convex function, right. So, this is a convex function. Okay, so finally, we come to the last category of investor, namely the risk neutral behavior. And we will consider the following graph. So, again we will look at w, and it is going to be a straight line. So, we have w minus, so this is going to be u of w minus, then we have w plus. So, I have here u of w plus, and then we have W naught here. So, this is going to be U of W naught, which is nothing but the utility of expected wealth, and which is nothing but, so this is actually the utility of the wealth level, utility of the expected wealth, and this is the same as expected utility of wealth, and so the certainty equivalent is going to lie at W naught. So, this means that if the investor has a linear utility function, then the investor is indifferent about the investment. And the reason why the investor is indifferent about the investment is because we have U of W naught, utility of initial wealth, is the same as the expected utility of the wealth after the investment. So, in this case, the risk premium is equal to phi of W naught Z tilde is equal to E of W tilde minus C E, which is equal to 0. So, in summary, U of E W is E of U W, and this is equivalent to U prime of W greater than 0, which of course has to hold in case of utility functions, but U double prime of W is equal to 0. So, this is because of the linear property. All right. So, what we have done so far, just to summarize this, we talked about the three different kinds of investors, and we identified the characteristic of each of the investors, and we defined what is going to be the risk premium, and through an illustrative example, we have established that in case of a risk averse investor, you will have a concave function. In case of a risk loving investor, you will have a convex function, and in case of risk neutral investor, you will have a linear function, and by functions I here mean that what is going to be the form of the utility function U of W, and in each of the cases obviously the U prime of W is positive, but in case of the risk averse we have U double prime less than 0, and in case of risk loving we have U double prime greater than 0, and in case of the risk neutral investor we have U double prime being equal to 0. All right. So, now we will look at three different examples. So, each example pertains to the three kinds of risk appetite. So, let us look at example A for the risk neutral investor. So, you consider an investment of 1000, and this investment is such that you could have a gain of 200 with probability half, and there could be a loss of 200 with probability half. And here suppose the utility function is the log utility. So, log utility, as you can see, it is a concave function, and the question is what is the CE and what is the risk premium. Okay, so let us try to answer this question. Now, since U prime of W is 1 over W, remember wealth is always positive. So, this U prime of W is greater than 0, and U double prime of W is equal to minus 1 over W square, which is less than 0. So, it follows that, so the investor is risk averse. Now, what is going to be the expected utility of this? The expected utility is going to be the utility. So, what is the amount of money then you can get? You can basically go from 1000 to either 1200 with probability half or you can come down to 800 with probability half. So, the respective utilities are going to be natural log of 1200 and the natural log of 800 with the respective probabilities being half. So, it is the utility into the respective probabilities added up. So, that gives us the expected utility, and this turns out to be equal to 6.8873. Now, my question was to find out what is the certainty equivalent and henceforth figure out what is the risk premium. So, by definition of certainty equivalent, E of UW is natural log of CE. So, remember that E of expected utility of W is the utility of the certainty equivalent, and the utility function is log of W. So, this is going to be log of CE. Remember that this is a natural log. All right. So, what does this mean? This means that certainty equivalent is going to be the E raised to the expected utility. And what is the expected utility? This is going to be E raised to 6.8873, and this is turns out to be 979.80. And therefore, the risk premium is going to be the original amount, all right, and minus the certainty equivalent 979.80, which is 20.20. Okay, now let us look at an example pertaining to the risk loving investor. So, it is the same framework. So, the same investment as example A. But we now have the utility function to be W square. So, you observe that U prime of W is equal to twice W, which is greater than 0, and U double prime of W is equal to 2, which is greater than 0. So, the investor, so from this two we can conclude that the investor is risk loving. Now, what is going to be the, so remember again, with a investment of 1000, it can go up to either 1200 with probability half or down to 1200 with probability half. So, accordingly, the expected utility is going to be the utility values. What are going to be the utility values? It is going to be utility of 1200 is 1200 square, and the utility of 800 is 800 square. Multiply this by half and add them to get the expected utility. So, this turns out to be 1040000. Now, to determine the certainty equivalent, so we go back to the definition, and this is going to be the expected utility of W is equal to utility of CE, and since the utility function is a quadratic function, so this is going to be CE square. So, which implies that the certainty equivalent is going to be square root of expected utility of W, which is square root of this. So, this is square root of 1040000, and this is 1019.80. And so, by definition, the risk premium is the original amount 1000 minus certainty equivalent 1019.80. This is minus 19.80. So, to conclude our discussion, I look at the last example. So, in this case, you will have the same framework as example A again, but in this case, I will let the utility function to be linear function. So, then U prime of W is equal to 1 and U double prime of W is equal to 0. So, the investor is risk neutral. So, therefore, what is going to be the certainty equivalent? The certainty equivalent obviously is going to be the same as your original amount 1000, and consequently the risk premium is going to be equal to 1000, which is the original amount, minus certainty equivalent, which is given here, and then this adds up being to be 0. Okay, so this brings us to the end of this lecture. Just to summarize what we have done again, so we have extended upon the concept of utility functions that we had discussed in the previous class, and we looked at two key characteristics for each of the three different kinds of investors in terms of risk appetite. Namely risk neutral, risk averse, risk loving, and risk neutral, and identified them in terms of the nature of the graph, namely concave, convex, and linear, and in terms of the marginal utility, and whether the marginal utility is diminishing, increasing, or simply equal to 0. And in order to illustrate this point, these three different nature of investors, we consider an identical example, but with different utility functions defined in a way that is consistent with the concavity, convexity, and linearity property of the three kinds of investors. And each of the cases we derive what is going to be their certainty equivalent and what is going to be their risk premium. So, this brings us to the end of this discussion, and from the next class we will continue more discussion on this in terms of certain parameters that are used in case of capturing the risk appetite, and then we will move on to talking about utility theory in the paradigm of portfolios. Thank you for watching.